All right, so let's take what we learned in 10.7 and 10.6 and apply it to these banking situations. Okay.
I don't think I have the right thing for this. I have things
All right, so we are mostly going to be dealing with exponential. There are some logarithmic banking applications, and we can use log to solve these, but this is mostly exponential. Now, whether this is growth or decay depends. Okay, if you're borrowing money from the bank, it's exponential growth for them and decay for you. You're losing money type of thing, or it's growth in your debt. So here we have two different formulas. Do these formulas look familiar? They should. They're actually very similar. You've seen these formulas before, and right in this box it tells you all the things. When we did half-life problems, we used a formula called y sub t equals y sub 0 e to the power of kt. Now, if you look at this formula, instead of y sub t, they have an a. And an a is the amount after n or t years. Okay, so it's like your final or your current amount. Your y sub 0, that was the initial amount of substance we had, like bacteria or plutonium or whatever. In banking problems, we call it P. We call it the principal. That's how much money you start with. You open an account, you put in $1,000, that's your principal. If the interest is compounded continuously, you use this formula, e to the power of RT. Very similar to what we had yesterday, e to the power of KT. Now, K was like our constant of variation. Now we use R, which is your interest rate. So in the half-life problems, we had to find K. In banking problems, we're either going to be given the interest rate or that's what we're trying to find. So there's actually less work in the banking problems. We write it as a decimal. All right, so we're going to see that in a minute here. 3% annual interest does not mean R is 3. Okay, it's going to be the decimal version of that percent. Okay, T is time as always. Now, compounded continuously is going to be the thing that earns the most interest. Okay, if this is like a savings account. But sometimes we have interest that's compounded after a specific interval. Quarterly, weekly, monthly, things like that. So how many times per year is the interest compounded? So we're going to use those formulas right there. So let's just go ahead and look at example 1. Sam. Well, there you go. We got 3 of them in here. So one of you is investing $800 into an account that earns 3% annual interest. Okay, let's go ahead and start off with what we know. If $800 is invested, which of those letters represents $800? P. Good. So let's go ahead and write that above there. Okay, 3% annual interest. Annual just means per year. So this is where we don't have to do a whole lot of work to find K, like as what we did yesterday. Here we're going to find R, but what is that as a decimal? 0.03. Because how much is a percent out of? 100. So 3/100ths is 0.03. All right. Then we get compounded monthly. All right. That is going to be what they use as a K. Sometimes we see this. Well, I'll just use what we have. All right. This is not the same K as yesterday. This is how many times the interest is compounded. And monthly means 12 times per year because there are 12 months in a year. All right, so let me write down the formula again. A equals P. We're not doing compounded continuously. We'll get to that part in B. So we're going to use this formula. And I'm just rewriting this from the top of the page. So it says, how much would he have? So that's what we're looking for. We're looking for A, the amount after 5 years. The principal we already identified was 800. The R is 0.03. Now, this is going to go in 12 times. So we're going to, the reason the formula works here is because that 3%, it's not like you get 3% every month. You get a 12th of 3% every month. And then up here for N, that's your time. Sometimes we see that for t, so that's going to be 5 times 12. Again, k is 12, because 60 times, then we're going to take that to the power of 60. 12 times a year for 5 years. That's why the formula works the way it does. We don't need to do any y1, y2, or algebra. We just need to type this in and get an answer. So this is where we're going to use our calculator. Just in the home screen, we're going to do 800, and then just type all this in. Definitely don't want to be doing this stuff without a calculator. Please make sure that both the 5 and the times 12 are in the exponent. If you don't have the updated version of a calculator, you probably have caret parenthesis. Make sure that 5 times 12 are both in that parenthesis or in the exponent. So we get an answer, and it's the right answer. But we're going to make sure this makes sense. Does it make sense to you? I mean, if you have no experience with banking, by the way, since this is dollars and cents, we can go ahead and round just to 2. If you rounded to 3, though, that would be fine. There is such a thing as a fraction of a penny. And if your banker was doing something with this, they wouldn't even round to 3. They wouldn't round at all, okay? So, or they would round, maybe in your favor, probably not in your favor. But there's different rules with that. But as far as when we write the answer, we can write it like this. If you were to empty out your bank account this day, this is how much money you would take. And again, it is possible you could round up or down on that penny.
What is compound interest?
So compound interest means instead of compounding the interest just every month, you're continuously compounding the interest. Okay, which, do you think that's going to make you more money?
Sounds like it, but I don't know.
Let's see. Real quick though, does this make sense? You have $800 after 5 years. We should have more money, right?
Right.
But notice it's not $1 million. You can't make $800 into that much more money than $800 in 5 years in a realistic situation. Okay. Although that's more money than we had when we started off with. Okay, so compounded continuously. It's the same problem set, but we're going to use this. And sometimes we have K here, sometimes we have T. I'm going to go ahead and just use the formula at the top, PERT. All right, so we want to know how much will we have. So again, we're looking for A. P is 800. R is still 0.03. And T is still 5 years. I want you to notice there's no 12 going on in this problem. We're thinking this will be more than 929, but we're not sure. Okay, when you type this in, please make sure you're using the E in your calculator. Okay, which is going to be second, ln, that's how you do e to the power of. Make sure the 0.03 and the times 5 is all in that exponent. Looks like this is 47 cents. So, did we make more money? Or did Sam make more money?
Yeah.
Yeah. Enough to really make a big difference? Not really. So, more money, but not that big of a deal. What would have made a much bigger deal is if the bank down the street said, hey, we'll offer you 3.5% annual interest. That would have been a bigger deal. Okay, so compounded continuously is better, but you can see here it's really not that much better. Okay, let's look at example 2. Mrs. Scott. Mrs. Scott has $3,500 in, excuse me, invested into account at 5% annual interest rate, compounded monthly. How long, so this is interesting, we're going to be looking for the T value here. How long will it take for her account to reach $5,000? Okay, so we got to, first of all, think, what formula are we going to use? Are we going to use the one with the E or the one with the K? Yeah. The one with the K. When do we use the E formula? When it says compounded continuously. That's the only time. All right, now we got to figure out where all these things go. So if Mrs. Scott invests $3,500, that's her principal. Okay, what is this 5% telling us? That R equals 5.05. Be really careful with that. If you make R 5, you're doing 500%, which will look like it earns you a lot of money, but it won't be correct. Okay, what about monthly? What is monthly telling us? K equals 12. And then 5,000, before we were finding A, here they're telling us A. So we're going to put 5,000 here, 3,500 here. I'm just plugging everything in. So we can put an N or a T. It doesn't really matter. I like using T. It's just hard for me to use an N, even though I know that's up in the formula there. But you could use either one. Now, in order to do this algebraically, you would have to actually do quite a bit of work. You'd have to divide by 3,500. You'd have to take log of both sides, natural log or regular log, but since this isn't an E, you even have more work to do after that. So I'm thinking lots of work. I don't really want to do that work. So what was the shortcut? What was the cheap way to do this? Y1 and Y2. All right, so this is something that I don't think, some of you are like, in theory, you got it. But in practice, you haven't practiced it yet. So you don't know how to do it yet. So let's all kind of tag along here and type it in. And then in place of time, make sure you put X. If you're in Y1 and Y2, you got to use X for your unknown. Okay, once you type it in, if I just do a zoom 6, will I see anything? Looks like no. Why not? Because it's 5,000. And it's 5,000 and Y equals, so I need to make my Y max at least 5,000. I'm going to make it 5,500. Now, I may need to change the X max as well. X is representing time, so I don't know that yet. So I'm just going to press graph. And if I can see the intersection, great. If I need to change the X max, then I will do that. So second trace 5, enter, enter, enter. I can see it, so there's my intersection right there. Now this is not talking about money, so we do need to round to 3 decimal places here. It's always 3 decimal places, but except when you're doing money, then you can go to 2. Yeah, but if you went ahead and went to 3 up here, that would be fine. Okay, we got one more example. I'm getting from the crowd that this is super easy. So that may or may not be easy for everybody. So I'm going to pause this video. All right, 2,000. That was your principal. This time they gave you the time. That was 7. Interest was compounded quarterly. We hadn't seen one like this. How many times a year is that? 4, and that's our K. So I know I'm going to use this formula, not the E formula. And you can use K times N or T right there. And so then it says the money was doubled. So that's telling us how much money we should put in A. So what would that be? 4,000. We don't know R, that's what it's asking us to find. K, here's 4, and up here I would do 4 times 7, or you could just write that as 28. Again, to solve this out algebraically, we could do it. We could divide by 2,000. We could rewrite it as a log and kind of go through those steps. But it's not really that obvious, so let's take the easy way out. We don't always have the option of taking the easy way out. We do here. If you wanted to divide by 2,000, you may want to do that because then that'll make your calculator graphing a little bit easier, but you don't have to, and I'm not, just to kind of show that it's not a necessary part. So I'm going to change that to 4,000. I'm going to change that to 2,000. I'm just kind of like going in and editing what I have. I don't know 0.05. This is actually where I'm going to put my x. And then that's going to be divided by 4. Oops. Divide by 4. And then up here in the exponent, that's where I'm going to do 4 times 7. Not 47. And any of this you could simplify if you needed to. My previous window went all the way up to 5,500, so probably my previous window is still good. But keep in mind, you can always start over with a Zoom 6 and then change that, and you could do all those things. You just need to see the intersection. Now there's going to be an intersection over here, and it looks like we have an intersection here. Could my answer be negative? In banking, is any of this stuff going to be negative? That doesn't really make sense. Okay, so don't find that intersection. Find this intersection right here. So second trace 5. Make sure that your little Spider-Man is closer to the intersection you want before you go ahead and do enter, enter, enter. And I get a really tiny decimal, which might be weird, except I'm looking for interest rate, which I know is a decimal. Okay, so I want to show you something. I want to go ahead and write out to many decimal places what you get. Okay, so this is our R, but that's not really the way I should answer the question. Yeah, 10, and if it didn't tell me how to round, I would do that. I would go 10.026% so that my percentage is to 3 decimal places, except it actually specifically says rounded to 1 decimal. So 10.0 or just 10%. That's our final answer. Calculate